Welcome everyone. Glad to be here. Happy you could all join me today. I'm super honored to be here. I haven't been to Devnexus in quite a few years. Unfortunately, I have a wife and a daughter who have birthdays in early April, and when the conference is usually held in early April, no matter when that is, I am going to be in trouble, so I can never come. But when I saw the conference was going to be in March this year, I jumped on the opportunity to submit my talk and was luckily enough accepted. So super glad that everyone could join me here today. We're going to be talking about deploying Spring applications to Kubernetes, and we want to do that with as little pain as possible. So that hence the title of Frustration-Free Kubernetes for Spring Developers. So before we get started, I just want to introduce myself. My name is Ryan Baxter. I've been on the Spring team for 8 years now. In fact, and the entire time I've been on the Spring team, I've been working on Spring Cloud along some of my colleagues that are here at the conference this year. Over the course of those 8 years, I've worked on pretty much all of the Spring Cloud projects that you can think of. Spring Cloud Netflix, Spring Cloud OpenFane, Spring Cloud Config, and more recently, I've been spending a lot of time working on Spring Cloud Kubernetes, hence the subject of the talk today. So if you want to get in contact with me while we're here at the conference, please feel free to stop by and talk to me in the hallway or whatnot. I'll be spending some time at the booth, the Spring booth, if you haven't checked that out. But if after the conference you want to get in touch with me, I'm Ryan J. Baxter on X and on LinkedIn, so you can always find me there as well. So like I mentioned in the beginning of the talk here, our mission today is really to get a Spring application on Kubernetes. And has anyone here done this already before? Okay, so some of you have experienced some of the pain that we're about to demonstrate today. But if you haven't done it before, maybe you've seen it demoed before, and it seems kind of simple on the surface, right? You build your boot app, you take a container, and you get that container, write a little YAML, and all of a sudden it's magically running on Kubernetes. And that works great from a demo point of view, but when we start to talk more about real-world scenarios, more complex applications or production environments, the complexity quickly blows up in your face, and it becomes a lot harder than it looked in the demo you might have seen. So, and it can become quite frustrating. So, for today's talk, we're going to build out an application that is a little bit more than your little Hello World application. It's nothing too overly complex or crazy, but it doesn't just print out Hello World, it actually does some other stuff. So we're gonna have a basic application. It has a single HTTP endpoint in it. The endpoint is just gonna ask a random person whether they'd like to go see some kind of random movie, right? And the random person's name is gonna come from another boot application. It doesn't have to be a boot application, in this case it is, called the name service. It just provides you with a random name, right? You hit this endpoint, it gives you a random name back. The list of movies that we get to pick from, that's going to be persisted in a database, in this case a MySQL database. And then because we're good cloud developers, we're going to externalize all of our configuration to a config server that uses Git. And then we also are going to use the Spring Cloud Discovery Server to look up where the location of this name service happens to be, because it could be changing every now and then. And so this does a little bit more than your normal Hello World application. There's a lot of moving pieces. So getting this to run on Kubernetes can be a little bit more challenging than just getting a single application running on Kubernetes. And so how would you go about doing this locally? If you were starting to build out this application and you just want to get started writing some code, you want to spin up some stuff locally, it's easy enough to really do, especially with the advent of test containers and the support for test containers that's now in Spring Boot, that becomes part of Spring Boot. So we can, luckily enough, spin up containers for all the different services that our application that we're building out actually needs, right? We can spin up a MySQL database. We can spin up a container for that name service. We can spin up a container for the config server and discovery server. And we get all that stuff running up fairly quickly. And now we can start leveraging those services as if they were in production and start building out our application. So we're going to take a look at that quickly as we walk through this demonstration. That's simple enough, and I'm sure some of you have probably done something like that already. But what if we want to then take that application and get it running on Kubernetes? Well, this is where we start to think about some stuff that's probably a little bit more complicated, right? So the first thing is we obviously need a cluster, right? We need some type of cluster to run this application on. So where do we go about getting that? We need to package our application in a container, and I'm probably sure you guys have seen Spring Boot's packaged into a container before, into a Docker container. It looks very simple. There's a lot of things that you don't think about as a developer when you turn an application into a container. So we're going to take a little bit of a deeper dive into that. Once you have the container and you want to get it running on this cluster that you theoretically have, it needs to be persisted, or needs to put that container in a container registry. And that container registry needs to be accessible by the cluster. So the cluster needs to know about where this container registry is. You need to know where that container registry is. You need to get one if you don't have one. And then that's just the steps to get our application running. And then we have to think about all the other steps that we need to get the services that we depend on running, like the MySQL server, the Spring Cloud config server, the discovery server, the name service, right? And then if you know anything about Kubernetes, Kubernetes loves YAML. So you need all the YAML to deploy all these things. And that becomes a lot of YAML very quickly. If you've never done anything on Kubernetes, you'll soon find out how painful that can be. So I'll start with the first problem here. Where do we get this cluster and container registry from? And luckily, there's no shortage of choices, right? You could go to the cloud, and you could use providers like AWS or Google Cloud or Azure or VMware Tanzu, or you could stick to doing something local on your machine initially. Pros and cons to each way, it doesn't really matter. But there's lots of different services that will spin up a cluster locally on your machine. Some of them here, K3s, Docker Desktop will do it. Kind, Minikube are just some of the options that are out there today. But for me personally, I like to, when I'm doing some development against Kubernetes, I like to spin this thing up locally. And there's a really cool utility that I've come across called Cattle Patrol, and the command line is ctlptl, but it's pronounced Cattle Patrol. And it spins up a cluster locally on your machine using any of these four choices. So you could pick K3s, Docker, Desktop, Kind, or Minikube, and it will go ahead and create the cluster for you using one of those services. And it also actually will create a container registry and set that communication up between the cluster and the registry for you. So in one single command, you get the cluster and you get the registry spun up for you, and it takes care of setting up your Kubernetes context and everything. So it's very simple, it's very easy. Got an example of it here. I've already got it up and running on my machine currently, so we don't have to spend time waiting for that to happen. It happens fairly quick, within a minute or so, but I just don't want to waste time doing that. But highly suggest to check that out as far as running something locally. Next, we need to take our application that we want to build, and we want to get it packaged as a container, right? And I'm sure you've all seen this sample Docker file that's on my screen here as a way to take a boot application and get it running as a container. And this actually works. It's 3 lines, because all you really need with the magic of Spring Boot is a JDK, and you can just run java-jar and run your jar file, and your application's up and running. And this is very attractive, right? But there are some problems with this. It's not as simple as it seems on the surface. So some of the downsides of using a Docker file. The first problem that I find frustrating is that I need to recreate that Docker file for every single application I'm going to put in a container, right? And if I have hundreds of applications, I'm creating that Docker file over and over again, and I have to maintain those Docker file across all those applications, and that's really just kind of a giant pain in the butt from a maintenance cost. There's also a lot of things that you don't think about when it comes to best practices as far as creating containers that can lead to inefficient, meaning they take up more resources on the machine that you're running on, and less secure containers, right? And I, for one, don't want to be the one responsible that exposes some kind of security vulnerability in my application because I didn't know about the best way to create a Docker file, for example. So security issues are always top of mind, and they're a valid concern, but they're not something that I want to really worry myself about all the time. So it would be great if something else could take care of that for me. And frankly, as a developer, I don't really want to worry myself about any of this stuff because my forte is writing code, right? I want to write code and build applications. I don't want to have to write Docker files and maintain Docker files. So it'd be great if something could take care of all this for me. And luckily, there is stuff that takes care of all this stuff for me, so I don't need to worry about it. And you don't need to either. And those two tools are called BuildPacks and Paketo. So for those of you who have not heard about BuildPacks and Paketo, it's basically just a really simple way to do all the things that I just talked about automatically for you. It's built into the Spring Boot Maven and Gradle plugins. So Basically, a build pack knows how to take your application code and transform it into a runnable artifact. So it knows how to create a jar out of that stuff, right? So the build packs, and there could be several of them, look at your application code and then determine how to create the most efficient jar possible for your application to run. And Baxter is a tool that uses a builder to determine which build packs it needs to use to turn your application code into a container. So those two tools together, they take care of all the best practices around creating containers for your application. Right? So it takes care of making sure that thing's going to run efficiently, make sure that it's always using the latest and greatest versions of things, so there's no security vulnerabilities, all that fun stuff. And the cool thing about Baxter is that it uses layering. So when there's a new version of something in your container, it can just go ahead and replace that one layer. So if there was a security vulnerability identified in the JDK layer, for example, it can go ahead and swap out that layer without having to recreate the whole container for you. And like I mentioned earlier, the best part about all of this is since you're Spring users, this support is all built into the Maven and Gradle build plugins that are in Spring Boot today. So you don't even need extra tools, you just have to have Docker running and it works for you. So we have a container, we have a way of containerizing our application, we have a cluster, we have a container registry. The next step is now to get that container into the registry and deploy it to Kubernetes. So here is the least amount of YAML that you could probably get away with deploying a very basic Spring Boot application to Kubernetes. It's about 50 lines of YAML, and that's the minimum amount. It can get much, much more verbose than this. Frankly, again, I don't mind writing a little bit of YAML, but writing 50 lines of YAML every time I want to deploy an application to Kubernetes is just kind of too much for me personally. So it would be great if I could take that off my plate. The other thing is there are a lot of best practices as far as running applications on Kubernetes and creating this YAML that I need to know about. And frankly, just like with Docker containers, I don't want to have to constantly be keeping up with the best practices, et cetera, with all that stuff. So luckily, there's a tool just like Baxter and build packs for creating containers. There's a tool that we can use that will generate our YAML for us for our application. So it's another open source project called Eclipse JCube. It's kind of like build packs, kind of like Baxter, but for Kubernetes YAML. So actually, JCube provides a whole bunch of different features related to deploying Java applications to Kubernetes. But one of the features that we're going to leverage from it today is the ability to generate the Kubernetes resources, aka the YAML, to get your application running on Kubernetes. And the way it does that is by looking at your POM or Gradle file and using some opinions that it has about best practices, etc. It will generate the YAML all for you. And just like in Spring Boot, where we have opinionated defaults about certain things, we allow you to override those defaults if you don't want them. Same thing with JCube. If you want to override the defaults that it has for generating the YAML, you can go ahead and do that using something called fragments. It's completely not necessary. You don't really need to do it all the time, but it is there if you need to customize the YAML in some way. But you're just writing small snippets of YAML in that case. You're not writing 50 lines of YAML, which is really nice. So the next thing that we probably haven't thought much about and haven't talked about yet is once we get the application running on Kubernetes, for example, we need to figure out where the MySQL server is going to be located. We need the username and password for that server and how to authenticate to all that stuff, right? And there is a specification that's part of Kubernetes called the servicebindings.io specification. And it tries to solve this problem in a standardized way for all the different kinds of services, not just databases, but any kind of service, third-party service that you might need to use when you're running on Kubernetes. And the way it does this is by exposing something called Kubernetes secrets, which is basically sensitive configuration information for connecting to that service. And there's an implementation of that specification that we have in the Spring portfolio called Spring Cloud Bindings. And Spring Boot build pack that we're going to use to build our container will automatically add that Spring Cloud Bindings dependency to our application when we create the container for our application. At that point, the Spring Cloud Bindings just needs to know where these secrets live. Where does the secret live for the MySQL service that we are trying to connect to? And we're going to tell it that it's mounted at this path, in a volume when we get deployed to Kubernetes, and then it's going to automatically look there for the secrets. It's going to find any secrets that it finds there in that path, and then it's going to automatically add the property sources to our application. So it will set the URL and the username and the password to connect to MySQL for us based on what it finds in that directory. So we're going to see that in a little bit more detail in a second. This is just a picture of what you need to do to tell the build pack where those service binding secrets live. So you can see this BPE_service binding root. That's just the path to where those secrets are going to be mounted when the application is running on Kubernetes. And then from there, Spring Cloud Bindings takes over and creates the property sources for us. So we have a lot of different moving pieces we need to think about as far as getting this application running on Kubernetes that we've talked about. And it'd be great to automate all that stuff because I don't really want to do it all manually. Luckily, there's another cool tool that we can use to do that too. It's called Tilt. It's an open source project. And it's going to allow us as developers to set up the application, get everything that application needs to be running on Kubernetes, up and running. And then also it's going to allow us to do some nice debug, reload type of functionality that's really beneficial as we're going through and building our application. So it's going to take care of building the image for the application, pushing the application to the container registry, running the Maven/Gradle goal to generate the Kates YAML to deploy the application. It's going to apply that YAML to the Kubernetes cluster, and it's also going to set up all the port forwarding as far as testing our application, hitting our application endpoint, and the port forwarding for the remote debug that we'll take a look at as well. So I mentioned there is a nice little developer experience that what comes along with Tilt. So the functionality that Tilt provides, along with the integration of Spring DevTools, we can get this very fast feedback loop where we make a change in our application, we compile our code, the new compiled class files automatically get uploaded to the pod running on Kubernetes. Spring DevTools notices that those class files have changed and will automatically restart the application context, just like it does when you're making changes locally on your in your application in your IDE. And so we get this very fast feedback loop that this very similar to what we would have as if we were doing development locally, but yet the application is running on the cluster in Kubernetes. That's not useful all the time, but it's useful in certain scenarios, so I want to demonstrate that as well. So with that, that's kind of all the slides I have. The rest of it is going to be live demo, so we're going to jump into some code and take a look at how things work. And please feel free to stop and raise your hand and ask me questions if something I'm saying doesn't make sense. Or you see something that I mess up. Yeah, sure. Tilt, yep. Yeah, so everything's gonna be used in combination. That kind of brings everything together. So we'll see that, yep. Yep, cool, good question. Yeah, so here I am in my IDE here. No, you can't see that. All right, now you can see it, okay. So here I'm my IDE here. We're gonna create a new Spring Boot app. Basically gonna build out the app that we had here, so. So we're going to call it Frustration Kates. And your #1 job as an audience is to yell at me if you see me mess something up while I'm typing. Like, just please yell at me and say, you really messed something up. Please go back and fix that because this is going to end horribly. So we're going to put it on temp here. We're going to use Java. We're going to use Maven. We're going to use Java 21, sorry. And we'll go next here. All right, so just like if you're using start.spring.io, you can, I don't know if you're familiar with this from IntelliJ, but this is essentially start.spring.io from inside the IDE here. We're going to add all our starters that we want to build our applications. So the first thing we're going to add is Spring DevTools. We're going to add test containers. So we're going to take a look at that as well. We're going to add Spring Web. We're going to add Spring Actuator. And we are going to add Spring JDBC, and we're going to use the MySQL driver. And then we're going to add a couple of Spring Cloud dependencies as well. So we're going to add load balancer. We're going to use the discovery client, and we're going to add the config client as well. So that takes care of all our dependencies as long as I didn't miss anything there. Doesn't look like it did. And we'll click create. So here we're going to go into our main application class. Is that text big enough for everyone to see? Cool. All right. So the first thing we're going to do is going to create a record called movie, and it's going to have a string, not a string, an integer ID and a string name. And then we are going to create a CRUD repository for that. So we're going to create an interface here, movie repository extends list CRUD repository. And we're going to add our own method in here to return a random movie. So it's going to return a movie. We'll call it random. And so we're going to say random r equals new random. And then we are going to say we're going to get a list of all the movies. Movies equals find all. And then here we're going to say I'm going to mess up there. List CRUD repository. What about come on. You're silly. Oh. Is it extend? No, it's extends. Extends list CRUD. What did I mess up? Did I mess up on my dependencies? Spring root starter JDBC. Spring data JDBC. That's what it was. Is that there now? JDBC. There we go. Okay. List CRUD repository. Movie. Integer. Okay, now we're on track. So you guys are supposed to tell me I made a mistake. Come on. All right, now we're going to turn a random movie. All right. From here, we are going to say we are going to create a configuration class. So in here, we're going to say class movie configuration. And we're going to return a load balanced bean a REST template. So call it REST in here, and we'll turn new REST template builder .build. Cool. And then we're going to create a REST controller here. So REST controller class movie controller. And in here, we're going to say private final movie repository, private final movie, REST controller, REST. And then we're going to say that's the constructor. And then we're going to create a get mapping at the root without the period. And we'll say this is going to return a string. We'll call this method index. And so first we're going to get a random movie. So movie equals movie repository.random. And then we're going to get the random name from the... What's that? You are correct, yes. That is a big mess up. Oop. Template. All right, thank you very much. That would have been bad. All right, so now we're gonna get a random name from the name service, and the way we're gonna do that is using the load balanced REST template. So that's gonna look up using service discovery where the name service is located using the name of the name service. A little repetitive. So we're going to say rest.getForObject URI.create HTTP, and the name of the name service is Kate's Workshop name service. Okay, and it's going to return a string to us. Okay, and then we're going to return here. We're going to say hi, name. Would you like to go see movie.name? Yeah, we should probably add a question mark. Sounds good to me. All right, so that's our application. Let's hope I didn't mess anything up there. So if we're going to run this thing locally, right, we could go down and use test containers to do that, like I mentioned earlier. And Spring does a nice job of trying to help us out here. It saw that MySQL is on the class path, and it wants to spin up, and we probably want to spin up a MySQL container for it. But there's a couple other services we want as well. So I have most of this configuration all typed out for us, so we don't need to spend a ton of time working through that. Let's see, import this class. So yeah, we have our MySQL container. We also spin up a container here for the name service, which is provided by us by the name service team, some other third-party team in my organization that's taking care of that app for me. We spin up a container that they've given us for that. And then you'll see here, we do something a little funky that you might not expect, is we implement and return our own discovery client. So why do we do that? Well, because it's a little bit tricky with the containers. So when this container starts, if we were to use something like Eureka, for example, it would try to register itself using the internal port that it started on, not the port that's exposed by the container. And at the time this application is starting inside that container, it has no idea what that port is going to be. So an easier way to go about doing this is to start this container first, and then once we know all the containers, where they're located, et cetera, we can create our own discovery client based on the location of all those containers and where their ports are. And that's essentially what I'm doing here. It's just a hack around the fact that starting the container that way doesn't need to know what external port is exposed outside of that container that we're going to actually use. A little bit of nuance, but that's the reason for that as well. The one thing you don't see here is a container for the config server, and that's because we actually need to start that in a different location. And I'm going to explain why we need to do that in a second here. I'll just put the code in for you. So here we just have start another generic container for the config server. And why do we do that here? It's because we actually need to specify the config server in the Spring config import property. And that needs to happen way before the application starts. Like as soon as the application starts, it needs to know where that Spring config import is set. And the only way to do that is to start it right before the main application class starts. So that's hence why we're starting it right here. If we were to put it in this configuration class here, this configuration class will run after the main application class has already started, in which case it's too late to tell it about the config server. So we need to do it way beforehand, and that needs to happen here. So that's the reason for that. Okay, with that, the other thing is that the config server is going to serve up the configuration from this YAML file, which is on the class path. So we're going to go ahead and create that YAML file. New directory, resources, new file. All right. And so all this is really doing is exposing, it's saying that we want to initialize our database with some code, which we're going to set up in a second, and it's exposing the actuator endpoints as well. So yeah, we want to initialize our database here with some data so we have something to look at. So we're going to create a new file here called schema.sql. And this is just going to be the basic layout of our table. So our movie table with our ID and our name. And then we're going to put some data in this table as well. So create data.sql. And I'm just going to put in my 3 favorite movies. No bias there. You can tell I'm a huge nerd. But those are my 3 favorite movies. The other thing we're going to do here is we're going to set some properties in our application YAML. First, we need to rename this to be a YAML file. And all we're really going to do here is really just we're specifying this Spring config import here for when our unit tests run, if you were to run the compile or to build the application on the command line. it would run the unit test. The unit test would fail because it didn't know where the config server is. So we do that to make that pass. And then we also specify the config server that we're going to use on Kubernetes, which we'll come back to when we get to the Kubernetes part of the demonstration. With that, I think we can actually run this thing. So if we go down here to our test frustration-free application class and try to run it, it's going to spin up all the test containers we talked about. It's going to spin up the container for the name service, for the discovery server, or not for the discovery server, for the config server, for the MySQL service. It's going to take care of binding everything for us. All that magic stuff is going to happen behind the covers with a nice integration within Spring Boot. And so our application's up and running with all our containers. So now if we go here and go to localhost 8080, we get, hi Ringo, would you like to go see Star Wars? We refresh this, we can see that it's going to randomly pick some names and some movies as we go through, right? So this is nothing special. This is exactly what you would expect if you try to run this thing locally, right? Now the next step is I want to take this thing that I've now built and I have running here locally on my machine using test containers, and I want to run it on Kubernetes, right? So like I said, I already have the cluster up and running. I use that tool, Cattle Patrol, to spin up the cluster and the container registry. That's already running. So I'm actually going to start off with the thing at the end in the beginning because then we can backtrack from there. So I'm going to create that tilt file using that tool called tilt that's going to automate everything for us. So I'm going to go here and create a new file called tilt file. And I'm going to place that here. And I'm going to explain what's going on here. So the first thing you're going to see at the top here is all these extensions, what tilt calls extensions. So tilt is extensible. You can create your own extensions to do certain things based on your tools. And I've created a couple of extensions that makes our lives a little bit easier. It's a little bit less verbose. Nothing I'm doing here is crazy. It just simplifies things. There's a lot less code that we need to write. So I put all these extensions up on GitHub. If you want to check them out, you can use them yourself. Feel free. I've just placed them there so anyone can benefit from what I've done here using the demo. All right, so we're just grabbing all those extensions that we're going to use. And the first extension that I wrote here is this basic extension that's going to provision a MySQL database on our Kubernetes cluster using the Bitnami Helm chart. So it takes care of deploying and managing and setting up the MySQL server. And the name of the database that's going to create for us to use is called frustration-free. That's what this parameter is here. It also takes care of creating the service binding secrets, right? So it's going to create that secret in the cluster that then other services can use to know how to connect to this database, right? So that's part of the service binding stuff in the integration with the build packs, etc. Then we're going to create a config map for configuration for our application that's specific to our app when it's running on Kubernetes. And we're going to create that config map from a file that's local here. So, and this could be any location really, but in this case, it's just easier to do it locally. So we're going to create a new directory here called case, where we're going to put some Kubernetes specific stuff here. So a new file. And all this is really doing here is that when we're running on Kubernetes, we're basically setting up our service discovery to point to a service discovery server on the cluster that we're also going to deploy, and we take care of disabling Eureka since we're not going to be using it when we're running on Kubernetes. The next thing here is kind of the interesting part around building our application. So containerizing it, building it, containerizing it, and putting it in the container registry. So that's what this custom build thing does here. So you'll see actually the main command is using the Maven Spring Boot build image plugin, right? This is part of the Spring Boot Maven plugin. This is what uses the build packs and Paketo to package the application in the container using all the best practices. And you can see it's going to be using this dev profile. So that's the dev Maven profile. So we're going to take a look at that in a second when I add it, because there's some things to point out there as well. This is also enables the live reload stuff that we were talking about. So the ability to compile the code on in your IDE and see those changes live pushed up to the running container on Kubernetes. This monitors these directories for any changes and uploads the class files up to the container, and then the dev tools will kick in and restart the application. So we'll see that live in action as well. This is another extension for deploying the config server. And then we have some configuration for our config server as well, which is going to be pulled from this YAML file as well. So we can deploy this config server and also push up this configuration for the config server when it's deployed to Kubernetes. So we're going to create this file here. And all this is really doing is pointing it at the config server to use a Git repo and also expose some of the actuator endpoints there. The next thing the tilt file does is deploy the Kubernetes discovery server for us to use. So that's done by that extension. And then we get to the interesting part around generating the YAML using JCube to create the YAML for us. So this bash script is basically going to execute the JCube Maven plugin. So I'm just going to create this, and we can take a look at what it does in a second. So really all it does is run this goal from the JCube plugin, which is going to generate, this is the goal that generates the Kubernetes YAML for us. That plugin's contained within that Maven profile, which we haven't added yet, which I'll come back to. And the logs are just thrown in here for debugging purposes. Then that running this goal results in this file being generated here. And then we just cat that file so that now the output of running this script is the YAML, right? So now we have all the YAML that was generated by JCube for our application. And then we modify it slightly. So again, a couple more extensions here to add the remote debug. So we need to expose the remote debug port in that YAML. And the other thing is we add that service binding. So we mount the service binding as a volume inside the container at the directory that we want the service bindings to live at. And that extension does that there. And then this call here basically takes that YAML and applies it to the cluster. The next step is to apply the YAML to run the name service on Kubernetes, right? And this, again, this is taken care of by this third-party name service team for us. They said, hey, we have this customized script that you can run that will generate the YAML to deploy the application to Kubernetes. Great, tell me how to do that. They told us how to do it, we did it here. And we create what's called a resource in Tilt to monitor that application deployment. And then we also create a resource for our application itself, exposing the ports that we want to port forward to and from the container, as well as any other resources it depends on, such as the config server, discovery server, and the MySQL server, so that it waits its turn to start up in order. That's basically it. So there are a couple things that I need to just backtrack on here. First thing is this create Kate's resource sh thing. This needs to be executable, so we need to make sure that that's executable so that Tilt can run it. So we're just gonna, I'll make this bigger so we can see what I'm doing. chmod. So we'll make that file executable. The other thing I mentioned is there's this profile in our Maven POM that we need to create that has JCube inside of it and also configures the Spring Boot Maven plugin to build a container correctly. So I'm going to add that profile here. And you'll see, where is it? Nope, right there. So here's the JCube plugin, right? So we're adding that plugin, so it's only enabled when we enable this dev profile. And then this is the extra configuration we're doing to the Spring Boot Maven plugin. So we're telling the build pack that we're using Java 21 so that it uses Java 21. We're enabling live reload by the build pack because that's disabled by default. And then we're also telling the build pack where all those service bindings are going to be located in the mounted volume inside the container so that it knows Spring Cloud Bindings can pick those up and automatically do its thing for us for that. The one last thing I need to do in this POM file, we're going to be using the Kubernetes discovery server. So we need to add the Kubernetes discovery client dependency to our application here as well. So there's a starter for that called Spring Cloud Starter Kubernetes Discovery Client. That's going to connect to the Kubernetes discovery server that's running on Kubernetes to figure out where the name service is located. So with all that done, we can actually run tilt now, and we just run tilt up. And this has a nice little web UI interface to see what's going on here. So it's analyzing your tilt file, figuring out what it needs to create and apply and deploy to the cluster. So here you can see it now. It starts to spinning everything up that was specified in that YAML file. In that tilt file. Sorry. So we got the name service, and actually that container is already up and running here. We have the discovery server, which that's up and running on the cluster now. The config server that's up and running as well. MySQL is currently being deployed here. It usually takes the longest, well, the second longest, I guess. But you can see our application is waiting because it said, I need this MySQL server to run. So we need to wait until that finishes starting up, which it has. And at this point, now our Tilt is actually taking care of building a container for our application. And if it's a little big, it'd be nice to shrink it down. But here is like, it's hard to see because it's going so fast. No, something happened. I didn't like that. What's going on? Dependency. Unable to invoke layer creator. Building image. Let's see if it happens here. Why is it failing? It's failing to connect to something. That's why. Let's see if that works. Come on. Try one more time here. Problem with live demos in the network, you're always dependent on making sure those things work. Downloading. All right, seems like we're making progress. Hey, all right, so we're pushing it up to the container registry. Sorry about that. So this ran Paketo and build packs, and it took the container, created the container for us, and now we pushed it up to the container registry, and you can see here the application is now starting and running on Kubernetes. So very cool. We have our application up and running. We can see our forwarded ports up here as well, and there we go. So the application here is now running on Kubernetes. And you see it worked just like it did before, right? Now, just a quick demonstration of things here. If I go back to my REST controller, and here, and I say, hey, would you like to go see the movie? And then I build this, so recompile things. Tilt's going to recognize that those files changed. It happened so fast you can't really see it. But it's going to upload the new compiled class files, which is this is the logging that you see. So it's uploaded the new compiled class files, and DevTools kicked in, restarted the application, and now I should see my changes here live. So now we can see, would you like to go see the movie has been added, right? I can also set a breakpoint here. I can run and go to my edit configurations. I can add a new remote debug configuration. And if I hit that, I can stop at my breakpoint. I can step through my code just like I would normally if the application is running on my machine. And this works not only if your cluster is local on your machine, but also if the cluster is in the cloud as well. The other thing I want to show quickly, we go and look at the environment variables here. This is, you'll see here, this is our Spring JDBC configuration, right? And this property source was added to our environment. That's all from Spring Cloud bindings, right? And that secret that got mounted inside the container. So I didn't have to do any of this. It just automatically got picked up based on the secret that was created by the Bitnami MySQL Helm chart, and that the fact that it was mounted inside the container of my application getting started here and automatically picked up by Spring Cloud bindings. So that's where all that comes from as well. So you can see that all there too. Yeah, so that's pretty much the presentation. I'm welcome to take any questions. If you guys have any questions about anything. This is the GitHub repo to the code. So it's all up here. But feel free to take pictures. check it out. Yep.
Yeah, so when you modify the like a REST controller, you added that movie, right? So what it does internally? Does it create a new like a
So what Tilt does is because Tilt is I told Tilt to monitor these directories, right? So it says sync anything that goes into any changes that happen in target.classes and workspace boot info classes. So when I recompile this, new class files get generated. It sees those files get generated, and then it automatically uploads them to the container. So if we scroll up here, this text that I highlighted here, so it says, we'll copy 8 files to the container. Oh, sorry. I forgot when I played from, sorry. Yeah, so what I was saying was this tells me what directories I want Tilt to monitor. So my target classes and then also my workspace boot in classes. So when it sees any changes in here, it automatically uploads them to the container. So what I was trying to show was here it says, you'll see it says, we'll copy 8 files to the container. So this is recognizing that those files changed, and it's going to copy those class files that it saw change up to the container. It doesn't actually restart the container. It doesn't create a new pod. It doesn't do anything. It just uploads them to the container. The pod stays running. Spring Boot DevTools notices that the class files have changed, and then it automatically restarts the application context like it would normally on your machine. Yep. Yep.
So Tilt its own standalone project?
Yep. So if you go to Tilt, just Google Tilt Kubernetes. Tilt.dev. So this is a separate project, open source project. So it's super cool, super useful. Any other questions?
Could you also deploy to, besides running locally, can you deploy it out to the
Yeah. Yep. So the same thing, if I had spun something up on AWS or whatever, a cluster on AWS or any cloud provider, I could literally just point my Kubernetes context to that cluster running in the cloud and just run Tilt up there, and it would do the same exact thing. It work the same exact way.
so in usually like in our project we'll have multiple repos for different microservices, right? And then so usually how does it work? We create a separate repo where we maintain this tilt file.
No, I mean, it's up to you where you want to maintain it, but I think it makes sense to put the tilt file in the repo alongside your code because it's specific to that application, right? You're going to need to deploy different services to get the application running, except different applications, right? This service needs a MySQL database, another service might need a messaging service, another, you might depend on other applications to come up, right? So it makes sense to keep the tilt file alongside the application code. Yeah, one file, right? And that way, every developer, if they need to get this thing running, they just run tilt up, and it spins everything up for them.
If let's say if I have 5 microservices, I have to run tilt command 5.
Yeah. Or it depends. Like usually it depends. But yeah, you could run tilt along 5 things, or you might have those 5 things running standalone in a cluster already. And you're just working on this one application at this moment, and so you're just going to run tilt up on that one, right? So it depends on your dev situation, right? But yeah, either or works. Any other questions?
So is there any other alternative to do the same thing?
Not that I found. If anyone knows any other alternatives, I'd love to hear them. I've been trying different things out for a while. There's another tool that doesn't necessarily, it can be useful in certain situations for developers in Kubernetes. It's called telepresence. It makes it very easy to, if you have an instance of a service running in a class path and you're trying to do development on that, an instance of that service running in a cluster, and you are trying to do development on that service, you can replace that running instance with like this proxy. It'll proxy everything that's coming, requests going in and out of that service down to your local dev machine from the cluster. That can be useful, but I view that as something that you might use alongside these other tools. I haven't found any other tools that kind of do this type of stuff in the Spring ecosystem anyways, or Java ecosystem. All right, if there's no other questions, thanks for everyone coming, and I'll stick around for a little bit. Thanks.